What's up, guys? Welcome back to another episode of Rad Talks. Today, it's going to be a solid introduction to the technical side of Rad Talks. Fun fact about me, I'm also a software engineer who's held several different positions over the last 10 plus years within the industry. And I'm going to share with you tips and tricks that I've learned along the way. I'm also going to do some interview prep and show you guys how to nail pretty much any technical interview that you're given. I have been on both the interviewing side and the interviewee side. My primary focus has been on the Android side, so I can also share with you a lot on that. Without further ado, let's jump right into the first thing I think is important for every software engineer, every computer scientist out there to fully understand. This is a solid concept, guys. If you don't know what I'm talking about yet, that's right. I am talking about SOLID. It's an acronym, SOLID. The S in SOLID stands for Single Responsibility Principle. What this means is every class should really only have one responsibility that it has. And really, every function should also have only one responsibility. And yes, you can just keep breaking this down, and how small do you really go for the responsibilities, and how loosely coupled or how generally grouped together do you consider responsibilities in order to be one responsibility? That part is partially subjective. However, there's sometimes it's pretty blatantly obvious. Think about it in terms of the practical side of this. It's a very practical concept. If I were to tell you to accomplish a series of tasks, let's say I want you to go to the gas station. At the same time, I want you to buy eggs. I want you to prepare dinner, and I want you to handle the budgeting. And at some point, I want you to go to the grocery store. Yes, those are 5 different things. They're not all related. They might be slightly related through financial things. So they're not even in a particular order. But if I tell you I need you to go do those and get those all done right now, and then if I wanted to do a status check on you, or someone else were to come up and say, hey, what are you doing right now? Oh, why are you over here? Why are you over there? Like, what's going on? It's going to be harder for you to be able to do all those tasks at once, harder for you to organize those tasks, and harder for anyone else who comes along to know what you're actually doing at this moment. Think of it in the same way. When you're talking about classes especially, do you want a class that's going to be all over the place, that is going to handle all of these tasks at once, is going to handle buying something and converting it between eggs and milk and the price of this and the price of that, and converting it to gas at the same time as filling up a gas tank? And that's going to be a nightmare to try to sort out. Or this class, some people try to call it polymorphism at this point, where this class today acts as a buy, and tomorrow acts as a sell, and the next day acts as an entire cart function, and the next day it acts as the checkout button, and the next day it acts as a call button. There's no rhyme or reason to do that. Everything should be broken down into one simple responsibility. Simple doesn't necessarily mean easy, it just means simple. It should have one specific task, that's all it's doing. There's another huge advantage to this, and this is why I said if someone else were to come along, will they really know what's going on? Same thing with programming. You're not writing your code in a silo. Well, some are, and that's wrong, but you shouldn't be writing your code in a silo, as well as you're not the last developer who's going to touch your code. There's going to be people who come on after you or that work alongside you. Let's say even in the small scale, you get sick or you find a better job. You're going to leave that company and someone else is going to come in and try to pick up your code. Or you came into a company and the person before you left and you're trying to pick up their code. Would you rather look at classes that have 10,000 lines of code and you look at them and have no idea what's even going on, the spaghetti code, and you just have to nuke the whole project and start over again? Or would you rather have classes that are nicely organized into very clear, concise responsibilities? And that's all they do. So you can go in, you can see the name of the class already is named accordingly and very descriptive, and that tells you exactly what that actually is. You go ahead and you click on it and you can see, oh wow, that's all this is, a simple thing. One of the places where I see this grow and creep way out of the scope of single responsibility is in data classes in Kotlin, for example. A data class really should just be a data class that represents a specific set of data for that specific part. What I mean is, if you have a class and it is dog, what you should have in there is the breed, the name, the age, things that represent a specific dog, things that you can have concrete values for, things that you're going to set. They should be vals, not vars. They should be set and immutable. What you shouldn't see in here, however, is you shouldn't see setters or getters. First of all, it's Kotlin, so that's going to be taken care of for you under the hood. But you also shouldn't see the to or the from functions that a lot of people throw in here, because that's really outside the scope of a data class or a data model. And that is actually responsibility of something else, whether it's a converter, a mapper, or an adapter. That functionality of converting something into this data class is outside the responsibility of a data class, which just represents the data, snapshot data at that specific time. So as you can see, it's really easy to go from, here's the data class, then we added a couple setters, then we added a couple tos, froms, then we say, well, age, how we added a calculate, so it's going to go ahead and calculate the age in here. Let's go ahead and calculate some sort of mixed breed. Let's go ahead and calculate this. Let's go ahead and calculate that. Next thing you know, you have a class that has 4,000 lines of code in it, and every single instance is using different parts differently, and some of the code is not being used in every single one of those. That's bad. That's not good. Again, it should just have one single responsibility, and that is to represent the data state of a dog, in this case. O stands for open closed principle. This is another one I see abused a lot. What it means is open for extension, closed for modification. A lot of people take this to mean inheritance is good. No. Inheritance is bad. If you can avoid inheritance, avoid it. Composition is better than inheritance. Yes, that's my personal opinion. However, a lot of people in the industry will agree with me on that statement, and because I got it from a lot of the experts in the industry myself, that's where I learned it from initially. Composition is better than inheritance. So how does that fit in with an open-closed principle? Simple. Interfaces. The reason this is accomplished through interfaces is in Java, it's the implements. You don't have to use the implements command in Kotlin. Basically, you're going to implement a specific interface, and you're going to be able to add that to whatever class you're at, and you can go ahead and extend out that class even further if you needed to, if you need more functionality on that class. However, unlike in the situation we were talking about with dog, where you have all of these mappers, tos, from, breed calculators, and age calculators, those then would live in the specific implementation classes. So if you had a specific type of dog that needed a age calculator, and that was very specific for every single type of dog in that class, then you would go ahead and do that. You would have the dog interface, go ahead and implement that in, and then you go ahead and add on, you extend out the functionality you need for your specific implementation that follows for every implementation of this new class. That is how you implement open closed with using composition over inheritance and without violating the open closed principle. L is for the Liskov substitution principle. This effectively is talking about being able to swap out the base class for another implementation without knowing it, and for it to be able to function, and to use the object of the derived classes without knowing it. Earlier, we were just talking about in open close, where basically you can extend down an interface. So this would also mean that you should be able to swap out and refer to that interface or to this new type of class, which has these age calculators or breed calculators built into that without having to change the implementation. So you can just swap those in, and you could use the dog interface, and it'll work just fine. This is also referred to as design by contract, where you're designing everything based off of that contract, which is the interface. So you are referring to the things of the interface and not to the concrete implementations in this extended out function that implements the interface. I is for the interface segregation principle. Again, the whole idea at the beginning when I was talking about with single responsibility, that sort of flows into this as well. No one likes a class that has 4,000 lines of code or 10,000 lines. I've seen some even more than that, believe it or not. Also, no one likes an interface that has 10,000 functions you have to implement if you don't even need to use those functions. That's a waste of the developer's time. That's going to be confusing for anyone new who comes into the class and won't understand what's going on. What that means is the interfaces should be grouped with each other in such a way that everything or every class that is going to implement these interfaces is going to use every single interface. If it doesn't need a function within that interface, then that should either be broken out into its own interface and implemented only on the class that needs it, or could even be just implemented as a concrete implementation if that's the only place it's going to need it and it's never going to be needed to be called in a way that would violate the Liskov principle we just talked about. If we're using animals as an example, let's say we're talking about dog, and maybe we might have a function on there that says get breed. So that's going to return the breed, and we can say that every single dog out there has some sort of breed. Even if the breed is unknown, we can say it has a breed. That's fine. But what we might not be able to say is an owner's name. Not every dog out there has an owner. Might be a stray, might be wild, might be feral, might be in a local shelter or something along those lines. So if we're implementing that on all of these dogs, we might not want the owner information that's related to that dog to actually be part of this interface. That might want to be a separate interface of its own. And that might be something we add to a specific type of dog. Something that indicates that it isn't actually a dog that is owned by an owner, so therefore we should have owner information. Whereas a stray dog should not be implementing an interface function, which is getting the information related to the owner himself, because there is no owner. I know, that's sad. Adopt your pets. Lastly, the D is dependency inversion principle. This means things need to depend on abstractions and not concrete implementations. Also, dependency inversion is just inverting the way you usually think about this. This is also the way that you would build out a framework as opposed to just a library. And one of the things, this is a great point, if you are on an interview and you're talking about dependency inversion, it's a great time to bring up, if you're on the Android side, if you're on any other, dependency injection and how you handle dependency injection. If you're on the Android side, this is when you should be talking about dagger and hilt. I guess you could talk about coin, but technically coin is a service locator and not a dependency injection framework. So if you want to get the bonus points, talk about dagger or hilt. They'll love it at this point. And how this ties in is you talk about breaking out pieces that can be abstracted out and reused, abstracted out, and then injected in. And that would allow you to be able to, like, say, for example, a service. So you can abstract out the service pieces, and then you can go ahead and inject them in where they're needed to be consumed. And that, my friends, is a solid introduction to the software side of Rad Talks. Don't worry, I will go more in depth in each one of these principles, especially as I walk through different coding projects and challenges and break those down. And I will highlight where these principles are in all of these code. I'm also going to go through and go in depth in each one of these and provide examples of the 5 elements that make up solid. Once again, it is single responsibility, open close principle, Liskov's substitution principle, interface segregation principle, and dependency inversion principle. Since we're talking software now as well, if you want me to break something down, any sort of concept that you may have found in engineering, or if you're a student, you want me to break something down on that as well, or if you're in the real world and you're looking for me to help you solve one of these problems or looking for me to solve a coding challenge, hit me up. I'll be more than happy to do that and post all of my code here as well for you. On the next episode, I'm actually going to do a coding challenge, which is going to break down almost every single coding challenge, take-home style coding challenge that is presented out there in the Android world. If you're looking for an Android job in the Android world and you're given a take-home exam, there is every single concept that they're going to want to look for is going to be in this video that I'm going to do next. So you want to stick around and find out. Secrets to acing these coding challenges next. And if you like this episode, go ahead and hit that subscribe button. And until then, stay awesome, friends.